Hey, everyone. Any questions, conversations, curiosities, stories, criticisms, accusations, poems?
I got my second dose
Oh,
for
did
the
you get all
vaccine.
beat up with from it? Are you all, was it
Well, I
today?
just got it this morning, so we'll see how it goes later on tonight or tomorrow.
Yeah, I've heard mixed results from people. And I was talking to someone a couple days ago who just had full blown flu. I mean, it's just bones were hurting. It's just like, oh, I'm just exploding from the inside.
No,
Uh,
yeah, I got the Pfizer vaccine, but I have like two friends. I got the Moderna, and they said their second dose, that's when they felt like crap. So hopefully,
Okay, yeah,
that's
this
how it
person was the
goes.
Moderna too that I was talking to. So hopefully the Pfizer is the gentler one, the kinder,
Yeah,
gentler,
hopefully.
soothing parent of a immunization. All right. Well, if I don't see you on Friday, I assume you are influed. You are
No, I'll still be here, but I'll just be really quiet and probably dead inside.
muted and vomiting and moaning and stuff. If you're like moaning and vomiting and stuff, you should definitely unmute just to give us, a little bit more of a physiological background. Like when you watch an old 90s sitcom and there's the laugh track on the back that you like Friends or something. They say something and there's like a weird bunch of like strangers laughing like on a recording. Uh that would be the equivalent in the physiology classic. Oh, COVID shot. Okay. So we're going to start sort of on altitude stress. We're not actually going to talk about altitude specifically today. I'm pulling up the chat box. Oh, Cameron, you got the shot too. And Nick and Lexi, you're all shotting. You're all getting all like shot up. So we're going to talk about the mechanics. So when we did heat and wind chill and cold and humidity and all that stuff, we introduced the whole package, the physiology as we went. This time we're going to talk about the undercarriage first. A lot of the machinery that is going to be affected by this stress for this whole week. Today we're going to do a bunch of heart and blood vessel and regulation and the types of sensors that are going to notice this stress, the sensors that are going to say, hey, just letting you know, I'm feeling something that isn't homeostasis right now. Where in that machinery is that happening? That's what we'll talk about today. And then we'll talk about the actual air, the conditions of the air, the quality and the not like pollen and stuff, but the nature of the air as it changes when you go burrowing into a tunnel or deep sea diving or you start climbing the mountain. And I mean, it really changes when you leap off that mountain and go up into the sky, up into like outer space. But we'll get to the actual stressors next week. This week it's the machinery, and then we'll kind of wind up those gears and animate them next week. So a couple of lectures about physiology, and then we'll start to introduce the environment and those interactions where those play out. But we began the semester with this, the range of stressors, and we've talked about some of them. We've gone through some of this stuff. We did thermal, right? We did heat, we did cold, we did physical loads in terms of sedentary stress and And what happens if you just sit around? Well, go through the alphabet and here's all your diseases. And overtraining syndrome, what that looks like, sort of the only domain in which Cellier is still given a trophy. And well, not the only domain. On that general alarm reaction is sound, but where his general adaptation presents without too much flaw. Overtraining syndrome, we had a little bit of starvation. We didn't go too deep into malnutrition or obesity or anything like that. We drugs and alcohol we got through, but we're starting this stuff now, the hyperbaric and the hypobaric, and then we'll end it with space flight. So we're going to start low, hyperbaric, and then we're going to go high, and then we're going to go super high. And then what I think we'll end the semester on, since this probably applies to you as much as anything, probably more than drugs and alcohol, and maybe more than physical loads, and certainly more than thermal stress, because you can just change your clothes or not go outside or turn on your AC or adjust your behaviors according to the heat. Right? And so, but we all succumb voluntarily or involuntarily to some sort of sleep deprivation. Oh, it's finals, or it's a whatever it is. Our circadian rhythms get very disrupted. Now, again, going back to this idea of what homeostasis is, and because when your blood alcohol content starts to creep up, that's not homeostasis, and we start to metabolize it. But we haven't really talked about that concept in a while. The concept of homeostasis, not the coinage, but the concept. 1865, Claude Bernard. Remember his um, internal environment, that milieu interior, and where he was saying we have this system of self-correction. We detect, we have sensors that are going to detect things, and little afferents that are going to send signals up to some regulatory center. It's just a bunch of hypothalamic stuff. And then some effector, so we can try to calibrate the body, correct whatever departure from homeostasis where we are coping with. And then, so that was 1865. 1926 is canon. It's Walter Bradford Cannon says homeostasis, the word, the nomenclature itself. And so this is a concept that we have identified long ago and investigated ever since, and come to understand with some amount of clarity. So, we talked a lot about the body temperature, and if the trigger for sweating, or the trigger for shivering, or any of these sorts of adaptation. So the anterior hypothalamus, that's going to detect your temperature rise. But you have probably in your house, you have a thermometer, whether it's a Honeywell or one of those like old circle ones with all the little ticks that you turn it, or whatever your thermometer looks like. You're going to have something. And often, you set it for 72 degrees or something, and there's a detector, there's a sensor. It's like, oh, we're at 67 or something, and the heat turns on to get up to 72. Oh, we're at 77, and the AC turns on to bring it back. So there's a sensor and there's an effector. And so you have your stimulus, you sense it. Let's send some afferents up, in this case with a heat, again, the anterior hypothalamus, getting our effector, and let's get some sweat glands going, or whatever it is that is going to occur to bring you back to homeostasis, to bring you back to that narrow, survivable window of temperature, of blood pressure, of ATP, right? Energy storage. We've been talking about that with the metabolism stuff, mTOR and AMPK, this sort of great energy sensor of the body, and your blood sugar. Let's maintain that somewhere between 4 and 5 grams for the whole bulk of you. Your 5 liters of blood, whatever. Throw a gram in every liter, something like that. your gas pressures, your acidity, your pH, your total body water. We talked a lot about that one in conjunction with temperature, the hydration, what hydration looks like. Same with alcohol, how it's going to affect your body water, ion concentrations, all of this stuff. Let's go through just a few of them. We'll do just a few of these things en route to the sensors for sort of acute altitude changes, what you're going to sense. So you remember the renin angiotensin aldosterone system. We talked about this one. Angiotensinogen, this little top guy up here. This, let's say it's a gal. It's a gal that comes from the liver. It's a lady, comes from the liver, and it's, you know, inert. And but if your kidneys sense, it's in circulation, if your kidneys sense that you have low blood pressure, your blood pressure is low, your kidneys sense that, they squirt out, they secrete some renin. Now renin, renin, that's something different. So sometimes people will pronounce it renin, commonly. It's a common pronunciation, but renin technically is something different. It's made in the fourth stomach of a calf. If you're a cheesemaker, you know your renin in your rennet, right? You know your renin, the protease in rennet. Well, let's slow down some time in transit as your shit's moving through. Let's curdle some of this stuff. That's renin with two n's. Renin is going to convert angiotensinogen, the liver lady, right, into angiotensin 1. And then angiotensin 1 gets converted to angiotensin 2 through ACE, angiotensin converting enzyme. So ACE is a major blood pressure medication, an ACE inhibitor rather, is a major blood pressure medication. But um, the angiotensin, I mean, we're looking at more effects than simply this converting enzyme, than simply going from, angiotensin 1 to angiotensin 2. We start to play in with things like the degradation of substance P, the degradation of bradykinins. There's other stuff going on too, but in general, the long-term regulation, the longer term regulation of your blood pressure is going to be the renin angiotensin aldosterone system. Your kidneys sense low blood pressure and they initiate this cascade. So long-term regulation of blood pressure. Let's get back to homeostasis. ATP. We've been talking about alcohol. We've been talking about fermentation, right? Throw some brewer's yeast in your carbs here, and let's go from glucose to pyruvate, and then let's go from pyruvate to acetaldehyde to ethanol. Now, in a person, right, we're going to use those enzymes to go the opposite direction. We don't make ethanol inside of us unless we have like a weird, yeast infection that's brewing us up some BAC, some blood alcohol content. But we have alcohol dehydrogenase and aldehyde, acetaldehyde dehydrogenase that's going to go in the opposite direction. But we know glycolysis. Glycolysis is the consumption of carbs. Now,